Welcome to solverfy.
Hacker throw the stone from the top of the cliff, and this stone drops the ground after 4.7 seconds. And as far as I understand from the task, we have to calculate the height of this cliff and some kind of velocity and magnitude and direction, which I cannot properly read. Please, if you need something else except from the height to be solved here, upload this task again with a more clear description. But nevertheless, I'll try my best to solve this problem, and hopefully everything what you need will be in the solution. So first of all, let's introduce y and x axis, and that is the initial velocity v0 and this angle alpha. Now let's find vertical and horizontal components of the initial velocity. So v0x equals to v0 times cosine alpha, and v0y equals to v0 times sine alpha. Now what we have to do, we have to calculate the total time of flight and use that to calculate the initial height. Let's do this. So the total time of flight equals time of increasing, like t1 plus t2, where t1 is the time needed to go from h0 to h max, and h max here is this height, and t2 is from h max to the ground. So therefore the vertical component of the stone is y0, h is h0, which is the height of the cliff, plus v0 sine alpha t minus gt squared over 2. So now what we can do, we can calculate t1. So that's the first equation, and we also need the second equation for the velocity. The vertical component of the velocity vy equals to v0 sine alpha t minus gt. So when time equals to t1, velocity vy is 0 because it's maximum velocity and nothing is moving. So yeah, and after that the stone will start to approach the ground. Therefore 0 equals to v0 sine alpha t1 minus gt. Oh, sorry. Yeah, there is no t here. It's v0 times sine alpha minus gt1 equals to 0. Therefore t1, or time of landing, equals to v0 sine alpha over g. Let's calculate this number right away. So it equals to 20.1 meters per second times sine of 41 degree, and that's divided by 10 meters per second squared. Let's calculate this number. It equals to 1.32 seconds, or 1.32 seconds, which is roughly 1.3 seconds. So that's t1. Now we can calculate t2 because we know the total time of flight. So t2 equals to total time of flight minus t1, or 4.7 seconds minus 1.3 seconds, which is 3.4 seconds. So let's look at the trajectory of the flight. After reaching the maximum point, the stone is going down, and h max, or total height, the maximum flight, equals to gc2 squared over 2, because t2 is needed to go from the maximum position to the ground. So now we can calculate h maximum. It equals to 10 meters per second squared times 3.4 seconds squared divided by 2. It equals to 57.8 meters, or roughly 58 meters. That's the total height. But this height is this height, h maximum, consists of two parts. So the first part is the height of the cliff, which we have to find h0, and the second part is this h. Let's label this delta h. So basically that is the distance which was covered during time t1. So then this delta h equals to squared initial velocity divided by 2g, or it equals to 20.1 meters per second times sine of 41 degree whole square divided by 20 meters per second squared. Let's calculate it. It equals to 8.7 meters. 8.7 meters. So therefore, actually no, let's just end up with 57.8 because it's more precise. So therefore, h maximum, as I said, equals to delta h plus h0, and h0 equals to h maximum minus delta h, or 57.8 meters minus 8.7 meters. Now let's calculate this number. It equals to 49.1 meter. So therefore h0 is roughly 49 meters. So that's the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.